Find the rational zeros of p of x equals 2x cubed plus x squared minus 13x plus 6. Write p of x in completely factored form. So our rational zeros theorem tells us that we can take the factors of the constant term and divide them by the factors of the leading coefficient. And that gives us a list of all the possible rational zeros. So the integer factors of 6 are 1, 2, 3, and 6, and it's also the negatives of those. And I like to just write my list and then do a plus or minus out in front. Okay? And then we divide these by the integer factors of 2, which are just 1 and 2. And again, it's plus or minus. And then we just go through and divide these and find our possibilities. So we have 1 over 1, which is 1, 2 over 1, which is 2, 3 over 1, which is 3, 6 over 1, which is 6, and then 1 over 2, and 2 over 2, which is 1. We already have that, so we won't write it again. 3 over 2, and then 6 over 2, which is 3, and we already have that in our list as well. And so here's our list, again, it's plus or minus all of those because we do all the positives and negatives that we're dividing as well. So this is the list of all the possible rational zeros of this polynomial. And then we just start testing them to see which ones actually work. And we do that usually with synthetic division. So we list our coefficients of our polynomial: 2, 1, negative 13, and 6. And then we start testing. And I like to start with my smaller numbers here. So I'll start with a 1. And I don't like fractions. I like to kind of avoid fractions if I can. So I have my 1 out here. Bring my 2 down. 2 times 1 is 2. 1 plus 2 is 3. 3 times 1 is 3. Negative 13 plus 3 is negative 10. Negative 10 plus 1 is, times 1 is negative 10. And then 6 plus negative 10 is negative 4. Now, we didn't get a 0 here. So we got a remainder. And if you get a remainder, that means that what we divided by here, which was x minus 1, is not x minus 1 is not a factor of our polynomial. So 1 didn't work. So now I move on, and you can just get rid of this work that you've done because, well, it didn't work out. So now we need to try something else. So now let's go ahead and try, let's just go to negative 1. See if that works. So bring the 2 down. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 1 is 1. Negative 13 plus 1 is negative 12. Negative 12 times negative 1 is 12. 6 plus 12 is 18. Again, we didn't get a 0, so negative 1 doesn't work either. Okay, and then we move on and try the next number. So I've done plus or minus 1. Let's do 2. Let's try 2. So bring the 2 down. Multiply 2 times 2 is 4. 1 plus 4 is 5. 5 times 2 is 10. Negative 13 plus 10 is negative 3. Negative 3 times 2 is negative 6. And 6 plus negative 6 is 0. So here we are. We've got this remainder of 0. That tells me that x minus 2 is a factor of p of x. Okay, so at this stage, I know that p of x is x minus 2, and then these are my coefficients of what's left over. Okay, so that tells me that I actually have left 2x squared plus 5x minus 3. All right, now I can keep going, or now I've got a quadratic. If you want, you can just try to factor that quadratic. I'm going to go ahead and just try to factor that because I much prefer factoring quadratics to testing a big list of numbers where I don't really know what's going to work out here. So to factor this quadratic, because I've got a 2x there, then probably have a 2x here and an x here. And let's do, I think, minus 1 and plus 3 is going to work out for us. That works out. That gives us this quadratic. So there's our factored form, and now we can get our all of our zeros. This is our completely factored form, and our zeros, we have x equals 2, x equals 1/2 if we set this factor here equal to 0, and x equals negative 3. And each of those has a multiplicity of 1 because the exponent on each of these factors is 1. Now, if you had wanted, you could have gone on here with the synthetic division and just kept testing things. But you wouldn't have anything work out until you got to -3 and 1/2. Okay, let's go ahead and do that just so you can see. I'll go ahead and do the 1/2 so you can kind of see that work out. We're only using the coefficients of what's left. We don't use the previous remainder of 0. We bring the 2 down. 2 times 1/2 is 1. 5 plus 1 is 6. And 6 times 1/2 is 3. And -3 plus 3 is 0. Okay, and so this tells me that 1/2 is a 0 of the polynomial, and the 2 and the 6 are the remaining coefficients. Now I want to point out here that if you were to write this in factored form from these zeros directly, you'd have your x minus 2, and then this 1/2 you'd say, well, that's x minus 1/2, and then the 2 and the 6, that's a 2x plus 6. And you'll notice this looks a little different than this over here. However, notice that you've got this factor of 2 in this third factor, and if you pull the 2 out and then put it with the second factor, you get the factored form that we used right here. Okay, so they look different, but they're actually equivalent. Okay, just different ways of looking at the factored form.